Now that we've got square root functions down, we're going to try graphing some cube roots. And we're starting out with the cube root parent function, just like we did before, most basic cube root we can get, and we're going to make a table and see what we're looking at here. The most logical starting point for a point is choice for a point would be 0. And I'm going to put that in the middle of my table, because I'm going to choose a few points on both sides. The cube root of 0 is still 0. So the point 0, 0 is on this graph right here. The cube root of 1 is equal to 1, because 1 to the third power gets you 1. So 1, 1's on the graph. And the next nice points, you would just kind of try numbers here until you think of like what the next nice cube root would be. But it turns out that the cube root of 8 is equal to 2. I'm skipping all the points between 1 and 8 because they're all decimals. The cube root of 8 is 2 because 2 to the third power gets me 8s. So I'm going to plot my point 3, 4, 5, 6, 7, 8, 2. That'd be right there. Now, on the other hand, we have negative numbers, and with square root functions, that was no good. We didn't like having negatives in the sense that they gave us imaginary answers, so we couldn't plot that. But with a cube root, we can take a negative no problem. The cube root of negative 1 is just negative 1. If you take the cube root of negative 1 to the third power still gets you negative 1. And the cube root of negative 8 is going to be negative 2. So my graph, 1, 2, 3, 4, 5, 6, 7, 8, is going to look something like this with my points right here. And when I make my cube root functions, I actually like to turn my paper. It's easier for me to draw that way. What you're going to be looking at here is something, let's see how well I can do this. Something similar to what you see going on right here. Still angled slightly upward on the ends. But this should remind you a little bit, if you look at it vertically, it looks a lot like a cubic polynomial, x to the third power, which makes sense because they're inverses of each other. But it's going to look like kind of a cubic function turned on its side right here. The ends should still be slightly slanted. They never actually level out, but they don't grow very fast at all. We're looking at like the slope of these graphs right here. As it goes along, the slope between 2 points gets really, really, really not steep. Our domain on this graph is all real numbers because it's going to keep going left and it's going to keep going right and hit everything. And our range is actually all real numbers as well. It doesn't grow very fast, but eventually it keeps on going up as it goes left and right. So cube root functions, domain and range are kind of easy. They're just all real numbers for both. Notice 0, 0 is on the graph, and up 1 over 1 still kind of gives us our point right here. We'd have to go down 1 over 1 to get this point. But if we can get these 3 middle points right here on a graph, we'll be able to use our shortcut, and that's what I'm going to show you on the next slide. So we're just going to practice on 2 examples here. Now, with all these types of graphs we've learned, you've got to be able to keep straight what shape they make. So when you see we're dealing with a cube root here, you think, okay, we're looking at that longish cubic function on its side, basically. If you saw a square root, you would know we're looking at the half parabola, etc. So what I'm going to do is go right 1 and down 2. So right 1, down 2 is going to take me right there. And my a out front here is a 3. So just like normal, I'm going to go up 3, 1, 2, 3, over 1. That gets me a point right there. Now 2 points isn't quite enough. If you remember in the last slide, I said we need 3 points. We need the middle guy, we need 1 on this side, and we need 1 on this side. Well, we went up 1 over 1 to get here, and we can kind of backtrack. We can go down 1, left 1 to get the other points. Same idea here. We went up 3 over 1 to get this point. We're going to go down 3, left 1 to get the other. So your 3 points are kind of in a line right here, but we know it's cubic. It's not going to be a linear graph, but those are the points we need to actually make it. I'm going to turn my paper a little bit here so I can actually draw it. It should not be very steep at all. Hits these 3 points and then levels out, or gets close to leveling out. Again, we're looking at something like this for our graph here. It should be curved. It should not be like straight jagged lines, but that's the basic idea here. Domain and range are all real numbers, nothing too wild there, and we're done. Last problem in the video, we're going to go left 2 and up 1. And we'll have a dot right there. We have a negative a in this problem, so we're going to go down 2 over 1. And then we need to backtrack. We're doing the reverse. We went down and right. We're going to go up 2, left 1 to get our other points. And now we're good to draw that graph. Again, tilting my paper here. When I draw this one right here, it's going to look something like this. You can see that it does fall from left to right because it's got a negative a in front, negative coefficients.